A logarithm is something that got figured out when they had a variable in the exponent. Okay? So if there's a variable in the exponent, let's say I have 2 to the x equals 8. Do you know what x is? No. Do. 2 what is 8? 2 cubed, yes. Here you know that x equals 3, and you could figure that, you can figure that one out. You can use logarithms for that, but you can figure it out. The ones you have for homework tonight, you won't need logarithms yet. We'll figure them out without the logarithm. But if I had 2 to the x equals 11, I don't know what x is, okay? This one would have to you would need logarithms to solve. You have a variable in the exponent, and it's going to be a number between 3 and 4. So you know it's a decimal between 3 and 4, but you don't know what it is. So you need logarithms to do that. And in the old days, they had slide rules, and you could figure out the logarithm of thing up to 4 points. And then they had the old calculators. We used to have charts. I had a chart that I used when I was a kid. We didn't have calculators, so we had to use a chart. So if I was looking for a logarithm, they also had to give you something that was on the chart, so all the problems were less complicated because they didn't have detailed. So that's when you would use it. You know that 2 cubed is 8, and 2 to the 4th is 16, and 11 is between 8 and 16, so it's going to be somewhere between 3 and 4, but you don't know what the exact number is, so you would use logarithms for this. And this is where you would put it in logarithmic form, which we're doing on Monday. Okay? So if I have problems like this, 3 to the n minus 2 equals 27. Okay? I could use logarithms for this, but I don't need to if I can change both sides of the equal sign to the same base. And if I take 27 and factor it, it's 3 times 9, right? And 3 times 3. You see that? So this is 3 to the n minus 2 equals 3 cubed. I just replace the 27 with the same base number, and it's 3 cubed. Got it? So, if 3 to this mess equals 3 to this mess, what do I know about the two messes?
3.
They're equal to each other. So, n minus 2 equals 3, n equals 5. In your calculator, you're going to put 3 to the parentheses 5 minus 2 and hit enter, and you should get 27. We can break down the 9 to 3s, or we can leave the 9 alone and break down the 81 to 9s, but you got to make them the same base. There are 2 ways to do this, and either way will get you the same answer, so it doesn't matter. So if I leave this 9 like this, when you have a 1 on the numerator, on the upstairs, that m belongs to the 1 and the m belongs to the 9, but 1 to the m is 1. So it's going to be 1 over 9 to the m. You understand that's the same thing because of the 1. If there was a 2 or a 3 there, then you would have to give the m to it, but you don't have to with the 1. And then I know that 81 is 9 squared. So I'm going to put the rest of it in parentheses because that square belongs to everybody inside the parentheses. So I have replaced the 81 with 9 squared. And I put the m downstairs because the upstairs was a 1. Not because I can do that with any fraction, but with a 1 on top you can. All right? Now that 9, you've got them base 9, but the one on the left is downstairs. How do you move that one upstairs? What do you do with the exponent when you move something from downstairs to upstairs or upstairs to downstairs? You make it the opposite sign. So in this case, this would be 9 to the negative m equals 9 to the 2 times m plus 4. So far, so good? And now we're ready. We've got the same base. They're exactly the same. 1/9 is not the same as 9. but 9 is the same as 9. So this mess equals this mess. We make negative m equal to 2 times m plus 4. And then this is basic algebra. Go ahead and complete that one from here. So when we change everything to base 3, we get that 81 is 3 to the 4th and 9 is 3 squared. So we replace those for those. Now on the left side, we have got to combine that into one base before we can proceed. What do you do with exponents? Like if I have this, x to the 3 times x to the 2. What do I do with those exponents?
Would it be 2x to the 5th?
Nope.
Or it would just be x to the 5th.
What do you think? That on the board, x cubed times x squared, is that x to the 5th? What is it? I always looked at this rule and I always forgot what to do. And I would just put something I knew in the calculator. Like if I had 2 cubed times 2 squared, that would be 8 times 4, which is 32. Well, that's 2 to the 5th. Oh, I must add them. Then I would know the rule. Like I back my way into rules when I get stuck like that, okay? So here we need to add those two exponents up here. And they're ugly, but it's okay. Let the math take you there. You got 5x plus 4 minus 4x. I just go ahead and distribute that 4. And that is x plus 4. So we have 3 to the x plus 4 equals 3 to the 2x minus 6. Are we ready now to move in for the kill? If we have 3 to the x plus 4 equals 3 to the 2x minus 6, what do we make equal to each other? The two exponents, right? So we've got x plus 4 equals 2x minus 6. So it's negative x equals negative 10, x equals 10. You've got to kind of see something here in order to get yourself out of trouble, basically. But if I have 36, I know is 6 squared, right? And the square root of 3/4 is the square root of 3 over the square root of 4. Does that make sense?
Yeah.
What is the square root of 4?
2.
So these two bite the dust. And you have 6 to the square root of 3 equals x to the square root of 3. Do you see your way in now?
Oh, okay.
X equals 6.